HCI, Lesson 12, Types of User Interfaces. So this is the 12th of the series of video lectures for HCI. Introduction. The user interface has two main components. The presentation language, which is the computer to human part of the transaction, and an action language, which characterizes the human to computer portion. Together, both concepts cover the form and content to the term user interface. The natural language interfaces. Natural language interfaces are perhaps the dream and ideal of experienced users because they permit users to interact with the computer in their everyday or natural language. No special skills are required of the user who interfaces with the computer using natural language. The display depicted in the figure, so that's below, lists three natural language questions from three different applications. Notice that the interaction with each seems very easy. For instance, the first sentence seems straightforward. Lists all the salespeople who met their quotas this month. So the subtleties of and irregularities residing in the ambiguities of English produce an extremely extracting and complex programming problem. Attempts at natural language interfacing for particular application in which any other type of interfaces is infeasible, say in the case of a user who is disabled, are meeting with some success. However, these interfaces are typically expensive. Implementation problems and extraordinary demand on computing resources have so far kept natural language interfaces to a minimum. The demand exists, though, and many programmers and researchers are working diligently on such interfaces. It is a growth area, and it therefore merits continued monitoring. Some websites, such as Ask.com, use a natural language for users to enter their search query. When the query is entered, Ask.com responds with a list of responses that matches the question entered by the user. So, question and answer interface. So, actually, the Google search engine also some sort of make use of natural language. So here are even some examples of natural language. So here we can see here that the user just typed change the age of ID 3 to 34, which is very straightforward. So this will change the age of this record with an ID 3 to 34. So unlike if you use the real select statement, wherein you're going to use wherein you're going to follow a particular syntax like update whatever the name of this table is, then set age equals 34 where ID equals 3. That's SQL. So what is natural language? If we're going to look at this at a glance, natural language is actually a combination of computer science and linguistics. So we have to combine them to arrive at our natural language processing. And of course, it requires AI and machine learning. Then we have the question and answer interfaces. In a question and answer interface, the computer displays a question to the user on the display. To interact, the user enters an answer, maybe by a keyboard stroke or a mouse click, and the computer then acts on that input information in a pre-programmed manner, typically by moving to the next question. Wizards used to install software are a common example of a question and answer interface. The user responds to the questions about the installation process, such as where to install the software or features. Another common example is the use of the Office Assistant with Microsoft products. When the user needs help, the Office Assistant asks questions and responds to the answer with additional questions designed to narrow the scope of the problem. Users unfamiliar with particular applications or not knowledgeable about a topic may find question and answer interfaces the most comfortable and quickly gaining confidence through their success. So here are examples of question and answer interfaces. So says here, are you sure you want to cancel the question? So that's already the question. So yes or no. Then here we have another here dialog. So the page at Stack Overflow says, are you sure you want to answer your own question? If you're responding to answer, blah, blah, blah. So we can click OK or maybe cancel. And here's another one. Welcome to Bittrex environment setup. So, and then you can click next or maybe cancel. So these are examples of question and answer interfaces. Menus. A menu interface appropriately borrows its name from the list of dishes that can be selected in a restaurant. Similarly, a menu interface provides the user with an on-screen list of available selections. In responding to the menu, a user is limited to the options displayed. The user needs to know the system but does need to know what tasks should be accomplished. For example, with a typical word processing menu, users can choose from the edit, copy, or print options. To utilize the menu best, however, users must know which task they desire to perform. Menus are not hardware dependent. Variations abound, and menus can be set up to use keyboard entry, like pen or mouse. Selections can be identified with a number, letter, or keyword, or users can click on the selection with the mouse. Consistency is important in designing a menu interface. So here's an example of an application using a menu interface. So this is actually Dev-C. So these are menus. So we have here the main menu and we have here the secondary options. So menu guidelines. Now, so to design menu, so the main menu bar is always displayed. So that should be our first guideline. The main menu uses single words for menu items. So main menu options always display secondary pull down menu. So if you go to look at this is our main menu, and you notice that it is only using single word, and these are now our secondary options. Then the third one, the main menu should have secondary options grouped into similar sets of features. So again, this is our secondary menu. You notice it is also grouped the features. So this is for opening and saving, this is for closing the project, this is for import and export. So it is grouped. The drop-down menus that display when a main menu item is clicked often consists of one or consists of more than one word. So if you're going back at this, so some here are more than one word. So print setup. So we have here close project, save project as, save as. So these are examples of menu. So unlike the main menu, which should be single word, the secondary one can be more than one word. Then these secondary options perform actions or display additional menu items. So if we go to look at this, so if we click on this, that's why we have here arrow here. That means if you click on this, it will display another set of menu. Or if you click on open, then this most probably will open a dialog, open dialog box. So it will be performing an action, or it will be opening another menu. Just like in this case in new and so here. So these are indicators that it will open another menu. And then number 6, menu items in gray are unavailable for the current activity. So if you notice there, we have here options that are grayed. So that means these are unavailable. So these are some of the menu guidelines. So here's another example menu. So again, single word. Then here we have here the word drop down. Then this will open another menu because of this arrow here. And the words can be consisting of more than one word or more. And the grade is actually disabled. Form field interfaces or input-output forms. Form field interfaces consist of on-screen forms or web-based forms displaying field containing data items or parameters that need to be communicated to the user. The form often is a facsimile of a paper form already familiar to the user. This interface technique is also known as a form-based method and input-output forms. Forms for display screens are set up to show what information should be input and where. Blank fields requiring information can be highlighted with inverse or flashing characters. The cursor is moved by the user from field to field by a single stroke of an arrow key, for instance. This arrangement allows movement one field backward or one field forward by clicking the appropriate arrow key. It provides the user good control over data entry. Web-based forms affords the opportunity to include hyperlinks to examples of correctly filled out forms or to further help and examples. So here's an example of a form fill interface. So where we can sign up, we have here text boxes and we have here drop down. Then we have here a button. Here's another example of a form fill interface. So we have here the labels, we have the text boxes, we have drop down combo boxes, and again we have here a button. So form input for displays can be simplified by supplying default values for fields and then allowing users to modify default information if necessary. For example, a database management system designed to show a form for inputting checks may supply the next sequential check number as a default when a new check form is exhibited. If checks are missing, the user changes the check number to reflect the actual check being input. Input for display screen fields can be alphanumerically restricted so that, for example, users can enter only numbers in field requesting a social security number, or they can input only letters where a person's name is required. If numbers are input where only letters are allowed, the computer may alert the user via audio output that the field was filled out incorrectly. The chief advantage of the input-output form interface is that the printed version of the filled-in form provides excellent documentation. It shows field labels as well as the context for entries. In addition, web forms can form incomplete forms to the user with an explanation of what data must be entered to complete the transaction. Often, fields with missing data are marked with a red asterisk. Web-based documents can be sent directly to billing if a transaction is involved, or they can go directly to a consumer database if a survey is being submitted. Web-based forms push the responsibility for accuracy to the user and make the form available for completion and submission on a 24-hour, 7 days a week worldwide basis. There are few disadvantages to input-output forms. The main drawback is that the user's experience with the system or application will become impatient with the input-output forms and may want more efficient ways to enter data. Then we also have the command language interfaces. A command language interface allows the user to control the application with a series of keystrokes, commands, phrases, or some sequence of these three methods. It is a popular interface that is more refined than those previously discussed. The command language has no inherent meaning for the user, and the fact makes it dissimilar to the other interfaces discussed so far. Command languages manipulate the computer as a tool by allowing the user to control the dialog. Command language affords the user more flexibility and control. When the user employs command language, the command is executed by the system immediately. Then the user may proceed to give it another command. Command languages require memorization of syntax rules that may prove to be obstacles for inexperienced users. Experienced users tend to prefer command languages, possibly because of their faster completion time. So here's an example of a command language interface. We type CMD in Microsoft Windows. So here we can type here now our command. Then we have the graphical user interface. I know you're familiar with this. So the key to graphical user interface, or GUIs, is the constant feedback on tasks and accomplishment that they provide to users. Continuous feedback on the manipulated object means that changes or reversals in the operations can be made quickly without incurring error messages. The concept of feedback for users is discussed thoroughly in a later section or later video. The creation of GUIs poses a challenge because an appropriate model of reality or an acceptable conceptual model of the representation must be invented. Designing GUIs for use on intranets, extranets, and more pressingly on the web requires even more careful planning. By and large, the users of websites are unknown to the developer, so a design must be clear-cut. The choice of icons, language, and hyperlinks becomes an entire set of decisions and assumptions about what kinds of users the website is hoping to attract. The designer must also adhere to the conventions that users now expect to encounter on websites. So here's an example of a graphical user interface. So this is actually PowerPoint. So we have menus, we have icons. Then we can have also the pointer, etc. And of course, we have the windows. So here's another example. This is a browser. So we have icons. We have here menus here. And then these are now touch screens. So this is our other interfaces. So we have the touch screen user interface. So the touch screens or touch sensitive displays allows a user to use a finger to activate the display. Touch-sensitive displays are useful in public information displays such as maps of cities and their sites posted in hotel lobbies or car rental facilities. They can also be used to explain dioramas in museums and to locate camping facilities in state parks. Touch-sensitive displays require no special expertise from users, and the screen is self-contained, requiring no special input device that might be broken or stolen. Stylus. The stylus is a small pointed stick that resembles a pen. Is becoming popular because of the new handwriting recognition software for personal digital assistants and mobile phones. Palms, combination mobile phones, and PDAs and pocket PCs devices have been a success because they are useful and easy to use. So I don't know how. I think there's something wrong. Additionally, but we know that they are useful and easy to use. So, additionally, they are portable and sell for a comparatively low price. There has been an explosion of fun and useful applications written for these mobile devices, including popular programs for restaurant reviews such as Sagats, and for popular games such as Sudoku. Data entry is also facilitated without a docking cradle so that you can synchronize data with your PC. Voice recognition. So with voice recognition, the user speaks to the computer and the system is able to recognize an individual vocal signals, convert them, and store the input. Voice recognition inventory systems are already in operation, and automobiles now feature voice input systems that respond to a driver voice commands to navigate or to change the radio station. An advantage of voice recognition systems is that they can speed data entry enormously and free the user's hands for other tasks. For example, driving. Speech input adds still another dimension to the PC. It is now possible to add equipment and software that allows a PC user to speak commands such as open file or save file to avoid using the keyboard or mouse. Users with limited mobility or impaired sight can benefit from voice recognition systems. So how do we evaluate user interfaces? So we could evaluate the user interfaces by the necessary training period for users, and it should be acceptably short. Then early in the training, users should be able to enter commands without thinking about them or without referring to a help menu or manual. Keeping interface consistent throughout the application can help in this regard. The interface should be seamless so that errors are few and those that do occur are not occurring because of poor design. The time that users and the system need to bounce back from errors should be short. Infrequent users should be able to relearn the system quickly. So that's all for this video. So these are the different user interfaces. Now these are just actually some of the user interfaces that we're using today. Thank you very much.